Welcome to Easy Math TV. This is part 2 of our Introduction to Continuous Random Variables and Their Distributions. Part 1, we talked about what our random variable x represents. It's basically the lifespan in years of a certain can opener. And we also introduced you to this idea of a probability density function, little f of x. So those values were all typed into columns A and B in our last video, and I explained what that meant as well. So if you did not see that, you'll want to go back and view that video and then come to this one, because you'll need that information to get set up for what we're doing today. So we're talking about can openers and their lifespans, all right, and the probability of the lifespan going past a certain amount, or maybe between certain values or whatever. So what we need is to fill in this third column here. So whenever you're dealing with a continuous random variable, the numbers that we need to calculate probabilities are the cumulative probabilities. So little f of x, the purpose of that was really just to make a graph. If we're calculating probabilities, we need the cumulative probabilities. So for this particular random variable x, we have the following formula. So that, again, this first formula here, what I would like you to do actually is get out a piece of paper and a pencil or a pen, or type this somewhere. Just get something out that you can put these three formulas down for your use, and you can put a box around them and basically just remind yourself of these three facts. The first one, though, is only going to be useful for this example that we're doing right here. But formulas 2 and 3 you definitely will need. Okay. However, for any continuous random variable, if you're talking about the probability of x being less than a number, that is the cumulative probability. That is the percentile. So that number is going to get entered into column C here, which we're going to go ahead and calculate in a minute. Before we do that, I would like to point out that there's an extra row here. So what I would like you to do is find the row that has x equals 2 and go up to, on the home tab, go up to insert and insert an extra row above it. Insert a row above it. So in that extra row, you're going to type equals 4/3 in column A, because that's the number 4/3. 4/3 of a year, basically 1 year and 4 months is what that is. 1 year and 4 months. And then in the f of x column, type 0.5625. So we don't really need that to be color coded at all. So that number just added an extra point on our graph. There's the point right there on the graph for 4/3 is somewhere between 1 and 2, and that's the extra point on the graph of little f of x. So we'll need that in a few minutes. Okay, so at this point you should have all these x's and these little f of x's filled in, and let's start with the cumulative probability. So the cumulative probability is going to equal 1 minus 1 divided by the number in column A. So that is the formula for the area up to that point. That's what that formula is. The area under the curve up to x equals 1. Now, since that's the starting point, we expect that area to be 0, and it is. Now let's fill that down. And these numbers are a bit awkward looking, so let's have them all have the same number of decimal places, out to 4 decimal places. So now they're all nice and uniform looking, okay? So these are the cumulative probabilities for these values of x. And that makes them percentiles. These are all of our percentiles. Okay, over here in the box, two more things that we need to make note of. For any continuous random variable, the following will be true. So every time we're calculating a probability, we're going to be using these numbers that you see here in column C. But it's just a question of how we're going to be using those numbers. So when you want the probability of x between two numbers, that's what you see here in this double inequality here. The probability of a number a less than x less than a number b. So little a and little b just represent any two numbers. Okay, any two numbers that x could be. And so what is the probability of x being between those two numbers? It's always going to equal the cumulative probability for little b minus the cumulative probability for little a. So you'll notice we're just going to be looking at the table for those two cumulative probabilities, and we're going to be subtracting them. Lastly, suppose you want the probability of x being greater than a number. So instead of the area to the left, suppose you're looking for the area to the right. And I want you to pay close attention to the direction of the inequality here. This is x greater than a. So you need to pay attention to that. Between now and the end of the course, we need to be paying attention to these directions of these inequalities, okay? Is it pointing to the right or is it pointing to the left? If it's pointing to the right, you want the area to the right. If it's pointing to the left, you want the area to the left, okay? So if we're looking at the area to the right, that's going to be using the complement rule, which is 1 minus the number in column C. So this probability will equal 1 minus the cumulative probability at little a. All right? So those are the three ways of calculating probabilities for continuous random variables, for any continuous random variable, really. The only difference is that if your little f of x changes, then the actual formula for the cumulative probabilities will change. But we're still going to be using these three methodologies. Okay. So I just moved that out of the way because I want to focus now on three examples. So for this random event x, what is the probability of x being between 2 and 4? So that's how we read that, x between 2 and 4. So if we look at our graph, there's the area under the curve between x equals 2 and x equals 4. There's our area. So that has a number associated with it. It's an actual physical thing that has an area. So how do we do that? We look in our table and we look for the cumulative probability for x equals 4, which is 0.75. Notice I'm completely ignoring column B. Anything under the little f of x is ignored. We don't touch those numbers at all. So 0.75 minus the number where x is equal to 2, and that cumulative probability is 0.5. So I don't need a calculator for that. That's 0.25. So that's 25%. 25% of all of our can openers will have a lifespan between 2 and 4 years. Next, what is the probability that x is less than 5? So there's an example that's just literally our, we're going to take the number directly from our cumulative probability table. We don't need to do anything special with it because it's area to the left. Whenever it's area to the left, your cumulative probability is fine. You don't need to do anything to it. So x is equal to 5, and the cumulative probability is 0.8, which is the same thing as 80%. So 80% of all of our can openers will have a lifespan of less than 5 years, or up to 5 years. Okay? 80%. And the last one here is the probability of x being greater than 6. So the direction of the inequality has been reversed now. Now we want to know what the probability of a lifespan above 6 years is going to be. So we need to use the complement rule, 1 minus something. So what is the cumulative probability that is associated with x equals 6? Because that's the number here. That's 0.8333, so I have to put that here after the 1 minus. So it's 1 minus the cumulative probability at x equals 6, which was 0.8333. So I'm actually going to need the calculator for that. 0.8333, and that's 0.1667. So equals 0.1667, or 16.67%. 16 and 2/3% of all can openers will last longer than 6 years. Okay. So there, that just gave you an example for each of the 3 types of calculations that we would need to make. The last thing that I want to do before we end this video is to just mention to you that there is a way of calculating your measure and your measure of center and your measure of spread. We do not have a means of calculating the mean and the standard deviation for this distribution. Okay. What we can do, though, is we can get the 50th percentile. So that's this. We can get the 75th percentile, which is Q3, and we can get the 25th percentile, which is Q1. So here's Q1. Here's your median. And here's your Q3. 75th percentile, 50th percentile, and 25th percentile. So I'm going to go ahead and highlight those values of x. Those are values of x, right? So down here, I'm just going to type median equals 2. And the interquartile range, which is Q3 minus Q1, what is that going to equal? Well, we'll need a calculator, I guess, because it's 4 minus 4/3. So I can actually type that as a fraction. But I don't like to subtract fractions in my head, so I'm just going to do it on here. When you want to subtract 4 minus 4/3, we do it this way. We type in the 4, and then minus, and then use a parenthesis. 4 divided by 3 is 4/3, close parenthesis, equals. Okay? So that's how I did it on the calculator. I put in the 4, and then I subtracted the quantity 4 divided by 3, because that's how a fraction is expressed in calculator. 4 divided by 3 is 4/3. And then I close the parenthesis and I hit enter. So I got 2.666667. That's basically 2 2/3, which is the same thing as 8/3. 8/3. So I'm going to go ahead and type that in here. Equals 8/3. There's your 2.666667. And I'm going to reduce the number of decimal places to 4 again. So our measure of center is the median because of the fact that this is such a skewed probability density function. It's very, very, very skewed. So my median is the measure of center, which is 2. And my interquartile range is my measure of spread, which is 2.666667. 0.6667 or 8/3. And there you have it. So there's your introduction to continuous random variables. I hope you enjoyed this video. I hope you got something out of it. Like, subscribe, comment down below. Share these videos with people that are taking statistics and might need some help, and other people in the class too. And I'll see you in the next video.